Here are some examples of nonlinear functions. The first one is nonlinear because we've got x to a power. In order for it to be linear, your x can only be to the first power. It can't be to any higher power than that. The second function is not a linear function because we have the x in the denominator. This is actually considered a rational function. The third example here is not a linear function because it's a square root function. So none of those are linear functions. None of them would have a graph that would be a straight line. When we have linear functions, what's special about linear functions is that the slope is the same regardless of where you are. So we say that they have a constant rate of change. The rate of change refers to the slope. So if you look at this first table that I had out here, if you notice the x values, each x value increases by 2 units. And each y value increases by 5 units. So because we have the same difference in all of our y's and all of the x's, this one is linear because it has a constant rate of change. If I take any pair of x and y's, if I subtract the y's and subtract the x's, I would have the same ratio. When we look down here, I have the same 2, 4, 6, 8 on the x, but if you look at the y's, here I have a jump of 10, here I have a jump of 5, or a difference of 5, and here I have a difference of 5. For it to be linear, that difference would have to be the same all the way across. So this function down at the bottom is not a linear function because this is different from the other two.